Hi, this is Mr. Gideon. So we've talked a little bit about the history of money, the struggles that have occurred over what standard to go by, how do we define money, how do we measure money, but not all money is created equally, particularly when you think about the role that time plays in how we value things, particularly money. We've talked before about inflation and how inflation can eat away at the value of money, and so obviously there's a difference between valuing money now and another point in time. In fact, there are different types of money and different values for money. We're talking about the difference between present value and future value. Remember when we talked about opportunity costs and how when you're weighing opportunity costs, you have to compare the benefits of some kind of project or activity with the costs. Not just the costs that are obvious, that are explicit, but also the hidden, implicit costs. That's going to apply here. But this can be difficult when you're trying to weigh costs and benefits, particularly that are occurring at different points in time. For example, let's say you have two job offers. One is from employer 1, who offers you a $1 bonus after year 1 working for her. Employer 2 says, I'll pay you the same base amount and I'll give you a bonus too, but that bonus is going to be up front. However, it's only 90 cents. So, ceteris paribus, which deal is better? Will inflation make a dollar not worth in 1 year what it is today? What if you take that 90 cents and you lend it out? Just put it in a bank, which is a form of lending, and assuming that that bank pays interest, would that be a better deal? Well, because these two offers are occurring at different points in time, the benefits would be paid to you at different points of time. We have to convert them so that we can compare apples to apples, not apples to oranges. And we have to convert future value into present value. So let's say that R is the interest rate. You could find the amount that you would receive 1 year from now as a result of lending today using this simple formula. The amount that you lend today, let's say it was 90 cents, 80 cents, 70 cents, $400, would equate to that amount plus the amount times the interest that's being accumulated. And you could reconfigure that expression here. But the amount you have to lend out today to have $1 in a year from now can be found by setting that equation equal to 1 and then solving for x. So of course you're probably asking yourself, so would that 90-cent deal be better or worse than $1 depending on the interest rate a year from now? If I took that 90 cents and set it aside in the future, would it be worth more or less than $1? You could actually figure that out. And I've shown a little bit of that work here. But the larger question is, in other words, the present value for 1 year from now. What does that equal? Well, it equals the future value divided by 1 plus R as the interest rate. Or more importantly, getting beyond the example that we had before, this formula is really important. PV equals FV divided by the quantity of 1 plus R raised to the nth power, because you'll use that to be able to convert back and forth between present value and future value. PV refers to present value, FV refers to future value, R is the interest rate for the period, usually the period is 1 year or a year at a time, and then N is the number of periods, usually the number of years. You can also use FV equal to the quantity of 1 plus R raised to the nth times PV if you need to find future value and you've been given the present value. So you've got both of these formulas. It's the same formula, but it's configured differently. Use this one up here if you're trying to calculate present value and you're given the other variables. If you have to convert present value to future value, you use this one. So then, let's say the interest rate is 10%, 0.10. You could plug that in and figure out that the present value of $1 is 91 cents, according to the numbers you've been given, going back to the two offers that we were originally considering. So in other words, the present value of that future dollar that you would get from employer 1, today, it's worth 91 cents. So thank you very much, I'll take that deal from employer 1. I know I seem cheap, but 91 cents is more than 90 cents. Now this is the same whether you're evaluating the value of benefits in that previous example or costs. You still convert numbers from present to future and back again using the same formulas. What would it cost you, for instance, today to have $1 in a year? 91 cents, of course, if you lend it out for the next year at 10%. What would it cost you today to have $5,000 in a year if the interest rate is 10%? Well, use the present value formula. Present value equals $5,000 divided by the quantity of 1 plus 0.10 raised to the first power. I didn't put the first in here because it's not necessary, but that would convert to $4,545 today. What if you got that bonus from employer 1 after year 2, though? And I bolded the number 2 here to draw your attention to the fact that now within our formula we do need that exponent. Maybe I was a bit careless before, but I'm not careless now. We have to have the 2 there. And when we use that with all the other same numbers, the present value now becomes 83 cents. So if employer 1 says, sure, I'll pay you $1 after year 2, I'm going to say, lady, stop slow playing me. I know about inflation. I know about present and future value. I'm taking the deal from employer number 2 because 90 cents today is worth more than 83 cents today in the present. Now the last part of this lesson has to do with net present value. So it's even broader than looking at one cost or one benefit. Net present value equals the present value of current and future benefits, so all benefits at all points in time, minus the present value of all the current and future costs. So for example, let's say you're choosing between project A, B, and C. Project A is going to pay you $100 right away and has no costs. Project B has a cost of $10 to you today, but in a year from now you'll get $115, more than that 100 in Project A. Project C will pay you $119 today and cost you $20 in a year. So the order of events, benefit and cost, is flipped from Project B. What should you do to evaluate, ceteris paribus, all other things being equal and not changing, which one is a better financial deal for you? Well, convert them all into apples. Convert all of these numbers into present value and see what it's worth today, or more importantly, what the net present value is, what your potential benefits are minus your costs in today's terms. Well, Project A is easy because we're talking only in today's terms. It's $100 that you're going to get paid today and no costs. So Project A is 100 minus 0, that equals 100. Project B, you have to take the $115 that you would get paid in a year and convert that into today. So you use the formula that I gave you before, and then you subtract $10 as your cost after you convert it to present value, and you end up realizing that presently the total benefit would be $94.55. For Project C, as I said before, the order of events is flipped, and so what you need to do is convert whatever future figures were included in Project C to present figures, and for you in that case we're talking about a future cost of $20, so now the $20 gets converted into present value using the formula that we gave. Both of these, Project B and C, use an exponent of 1 because we're only talking about a 1-year time frame, but once you convert the $20, it becomes 119 minus this, which is a total benefit of $100.82. Once everything's been converted to present value, it becomes obvious which choice you should be making. It's Project C. Powerful stuff for real life, huh? Hopefully you can use this at some point in the future beyond this class.